Hello, everyone, and welcome to today's workshop. This Marine Data for South America workshop from the Copernicus Marine Service. Welcome, everyone. My name is Andrea Carvalho from Mercator. I'm a training officer at Mercator Ocean International, and I'll be your host for today. So we will have 2 days workshop, and today we will have a more introductory session where we'll tell you about what the Copernicus Marine Service is about, what sort of data you can find there, and what sort of applications you can do with the data we provide to you. Before we start, we're gonna go through some house rules, some guidelines to help you follow this workshop in the best possible way. So as you have noticed, maybe already at the bottom bar of your screen, of this live session, you will find the globe symbol, which means that there's a live interpretation. So this workshop is being recorded, is being also interpreted in Spanish. So you can choose if you want to listen to what we will be presenting in English, which is the original audio, or in Spanish. So if you take a look at the bottom bar again of this screen, you will see the globe symbol and you can choose your language. So also another rule, please don't use the chat that you see on your right-hand side for your questions. You can use it for small talk or to say hello to us. Feel free to do so. Or if you have a more technical question. But if you have any other question, you can, or we'll use another platform. We'll use the Q&A section in the website and your page, in the events page you have access to. And so the top bar of your page, you will find the Q&A button. If you click, you will see an area dedicated to the Q&A, and that's where you can ask your questions to our speakers today. And so speaking of our speakers, today we will have many interesting presentations. We will start with an introduction. I will give it to you about the Copernicus Marine Service, and then we will go to a more in-depth presentations about the products we provide to you. We will have Rian Giseng from the wind satellite product producers. She's representing the wind tech from the Copernicus Marine Service, and she will tell you more about those type of products. We'll have Valentina Junta from Mercator Ocean International. Who's going to tell us about the model product. And Fernando Manzano from Puertos del Estado is going to tell us about the in-situ products provided by the Copernicus Marine Service. Later on, we will have some more presentations about specific applications of this product. How can you apply all this data to specific studies in your area? If you are coming from Brazil, Argentina, Paraguay, South America, and you have a study around there, if you already work with the Copernicus Marine Service or other marine data, you will, I'm sure, learn from these examples. So we'll have Barbara Crisi Franco from IFAECI, sorry, and Gonzalo from CISES, and Dr. Paulo Nobre from ENPE. And later on, we will have Cedric Jordan from Mercator as well, who will tell us about the learning materials and how to access the user support pages. Okay, so now we will jump right through to the first presentation, or just a little overview about what the Copernicus Marine Service is about, just to introduce you to it if you are not familiar with the service yet. So I'll start with the Copernicus itself. Copernicus is a program created by the European Union. It's a European fully funded created program dedicated to the observation of the Earth. And to be able to better understand different systems of the planet. And so it includes 6 services: the atmosphere, the marine, the land, climate change, the emergency, and the security services. And it provides free of charge and open source data, products, and information about all these different systems of the Earth. And yes, so the marine service, it focuses on monitoring the marine environment. And so how do you access the service? Through its website, marine.copernicus.eu. It's free to follow, to access the website, and to download any product. There you will find an extensive catalog of products. All of them are scientifically qualified, and they are user-driven, so they are constantly upgraded and improved and taken into account. Also experiences of already users of the service. They are easy to download as well, and they are open and free of charge, as I said. What kind of data does the Copernicus Marine Service provide? Provides data on the blue, what we call the blue, the white, and the green ocean. So blue, it's all about the physics component of the ocean. So all that has to do with currents, temperature, waves, wind, sea level. The white is the ice, so ice coverage, ice velocity, ice concentration, all the frozen part of the Earth. And the green ocean is the biogeochemical component of the ocean. So all that has to do with phytoplankton, nutrients, chemical composition, CO2, oxygen, etc. So yeah, as I said, this is a bit more descriptive of the parameters you can find. These are just a few examples. And in terms of the coverage, sorry, too fast. In terms of temporal and geographical coverage and the type of data the Copernicus Marine Service provides, it is quite varied. It includes in situ data, which is direct measurements in the sea. It includes satellite observations, and then there are used to validate model data. And then you can find data that are, sorry about that again. You can find data that it is measured right now, that it is from right now, but you can on real time, what we call real time, but also from the past all the way back to 30 years, what we called reanalysis or multi-year, and also provide forecasts 10 days into the future. And in terms of geographical coverage, we do cover 5 areas or 6 European regions, as you can see on the globe. And then we also covered the global ocean, so also South America, all the rest of the globe. So besides products, specific products we provide, we also provide ocean monitoring indicators or data related to the climate and to the climate. And in this case, the monitoring indicators are key variables that help us understand how is the ocean at the moment, how is the health of the ocean at the moment. These are also free accessible and free of charge, and they cover the past 30 years of their long-term analysis. You will also find in the Copernicus Marine Service website a visualization tool, what we call My Ocean. You have 3 versions of this visualization tool: the Learn, the Light, and the My Ocean Pro, which we'll have a presentation tomorrow to show you how you can select a product and then see it or visualize it in a very fun way. I find you will see it's very interesting, and this gives another perspective to the data. So besides data, we also provide information, and one of the ways we do that is by publishing a yearly report on the state of the ocean. And we also provide Ocean State Report summary, where we try to target less scientific communities, so more policymakers or the media or even the general public, so to make sure that the information gets to everyone. Another way we do that is also by creating 2 pages called the Ocean Explainers and the Ocean Climate Portal, where we explain some concepts, oceanographic concepts, or current threats that the ocean is facing, and we try to explain it to everyone. Also, the Ocean Climate Portal gives a perspective on the indicators, key variables of the climate in the ocean, but in a more accessible way for everyone. So as you can see, we try to reach a bit of everyone, and it's the data that we provide and the information, it responds to different needs and or markets, as you would want to call it, from science and innovation to policies and but also to coastal services or economy sectors, for example. So today you will hear about 3 use cases. So 3 practical applications of the data we provide, but in the website you will find many other examples, and we invite you to visit the website and also learn from these examples. And if you are a use case yourself, we also invite you to submit your project as a use case. We're always interested to learn more about how the data has been used everywhere in the world. So besides this, we also provide training. So we try to make sure that the data is not only available to everyone, but also that we can help people use it, and so make it as accessible as possible. So we organize workshops like this one, but we also organize train the trainer workshops and other hackathons or other events to try to engage with users. And that's all for me for today. I hope we got a little glimpse of what the service is about, and now we will delve a little bit more into the products itself, and then later on into the specific applications. So yes, I'm inviting my first speaker, Rian Giseng. She represents the data producers involved in the wind satellite products. So Rian, whenever you want, the floor is yours.
Thank you, Andrea. I have some difficulties. I cannot see any slides at the moment.
It's coming. Yes.
Perfect. Hello, everyone. My name is Rianne Giesen. I'm from the Royal Netherlands Meteorological Institute, and we produce ocean surface wind products for the Copernicus Marine Service using satellite observations. So today I would like to give you an overview of our products. And here is first an overview in a table. So we actually have 5 different products, 2 level 3 products. So these are actually the observations, satellite observations, but then regridded to a regular latitude longitude grid. We have a near real time and a multi-year product. So the near real time product only spans the past, well, actually quite a period as well, but the multi-year period is a much longer time series. And these are essentially the same products because they contain the same variables, but yeah, they're based on different scatterometer missions. And then we have 2 level 4 hourly products, both in near real time and the multi-year version. Also, they are complementary to each other. The near real time product only covers the last 2 years, and the multi-year product starts currently in 1999. And then finally, we have a monthly product, which provides monthly average wind variables. And in the rest of the presentation, I'll go through these products in more detail. But first, a bit more about a scatterometer, because that's the satellite instrument that we use in our products. So a scatterometer is an active instrument, so it sends out a radar signal, and that signal is reflected at the ocean surface. And the instrument measures how much of this signal is returned to the satellite. And this actually depends on the roughness of the ocean surface. So if we have a very flat surface with no wind, then hardly any of the signal is returned to the satellite. And the more wind there is, the more of the signal is returned. So there's a relation between the backscatter of the signal and the wind, and that's how we determine the wind at the ocean surface. There's different types of instruments. There's 2 examples on the right. One is a fan beam scatterometer. These usually operate in C-band frequency, which is actually scanning like horizontal lines. And then there's the pencil beam scatterometer, which more scans circles along the line of flight. And there's some differences. Well, the pencil beam scatterometers are generally Ku band, so that's a smaller wavelength, so higher frequency. And there's some other differences. For example, the C-band scatterometers are less sensitive to rain, but there are more limitations at extreme wind speeds, and the other way around for Ku band scatterometers. So here's an overview of the scatterometer missions that we use in our products. The first longer scatterometer mission is from ERS, starting in 1999. And then there's a follow-up of different missions. There's always a bit of overlap between missions, so we can tie these time series together. In the multi-year product, which then starts in 1991, we have 6 different scatterometers. And in the near real time product, which starts in 2016, we have actually 7 different scatterometer missions, of which 5 are still operational. And some of these are C-band and some of these are Ku band. So first a bit about the level 3 products, about the coverage, because that's also different for the different scatterometer instruments. In the products, we provide daily files with the daily, a daily aggregation of the orbits over that day. And we also separate into ascending and descending orbits. And in this way, there's hardly any overlap in the product. So there's only some overlap at the higher latitudes. And here you see some examples actually from a couple of days ago, which was quite interesting because there was this tropical storm before the coast of Brazil, which is quite a rare phenomenon. And you can also see that in some of the images where the tropical storm was captured. And I also put here the overpass time. So this is a local solar time. So the local time actually, it's an approximate. It's not always exactly this time. But you can see that the 2 METOP satellites, they pass over around the same time, but their orbits are a bit shifted. So there's overlap of the orbits, and sometimes they also complement each other. And then for the Haiyang satellite, so this is a Chinese satellite, we have one Haiyang 2B, which actually has a fixed time, just like the METOP satellites. And then Haiyang 2C and 2D, they actually have a regressing orbit. So it changes in time what time the satellite comes over. But they're always 12 hours apart. So if you have the Haiyang 2C and 2D observations, you have actually an observation every 6 hours. So let's zoom in a bit more on this tropical storm to show you which variables we have in the product. So we do not only have wind speed, because there's we're looking at the ocean surface from different angles with multiple antennas. We can also derive the wind direction, and we actually, well, there's also wind direction in the products, but we also do separate into the zonal and the meridional component of the ocean surface wind. And next to that, we also calculated the divergence of the wind field and the rotation or the curl. And we do not only do this for surface wind, but also for surface wind stress, because it's an important variable for many ocean applications. So this is just an example to show this. And well, the funny thing here is that there's an overlap of two orbits, and one is actually at the beginning of the day, and the other one is at the very end of the day. So it's almost a day apart. So you see the storm actually 2 times in both of the orbits. One in the first orbit is quite strong, and at the end of the day, 1 day later, it's actually already much weaker. And also in the products, in addition to the scatterometer observations, all these variables we have, we also collocate these observations with model winds from the ECMWF model, and we include this also in the product. So you can always compare the scatterometer observations to the model winds. We also did this quite a bit also for verification and to identify actually whether there's any biases. And this is an example from a paper where they calculated the bias between scatterometer observations and the ECMWF era 5 reanalysis over a year. So this is these are the biases that you can still see after a year. So this is quite persistent biases, and also quite large, up to 1 meter per second for the wind components. And there's also the transient wind, which is a measure of wind variability. So this shows that the era 5 reanalysis has less variability in the wind than the scatterometer observations. And we actually use this to produce our level 4 products. So I didn't explain that yet, but level 4 is either a combination of multiple instruments, or a combination of also with model variables. And what we actually do is that we calculate this scatterometer model bias over a couple of days, in this case 20 days, to actually have good spatial coverage from the observations. And then we add this bias to the uncorrected ECMWF model wind field. And the ECMWF model wind fields are hourly wind fields with global coverage. And then we add this bias correction to correct for the persistent biases that we see between the scatterometer observations and the model. So yeah, it's because the biases are smaller than the speeds themselves, you don't see a very large difference, but you can imagine if you look over a longer time period that this actually makes a difference whether the wind or the ocean surface is pushed in a certain direction or a slightly different direction. Yeah, so we have these hourly level 4 products that they were introduced into the catalog 2 years ago. They are based on hourly bias-corrected model wind variables. And then we have both a near real-time product, which is based on operational model wind fields, and have an 1/8 of a degree horizontal grid. For this, we use a pair of scatterometers from METOP B and METOP C, starting 2 years before present. And then there's a multi-year product which uses the era 5 reanalysis wind fields. And then we have both a data set at an 1/8 of a degree horizontal resolution. This is because the METOP ASCAT instrument has this high resolution. And then for earlier periods, we use a slightly lower resolution, currently using observation from QuickScat. but we are planning to extend the data sets back in time with observations from ERS-1 and ERS-2. There's a bit an issue with the ERS, well, not an issue, but the thing is that, as you can see in this figure with for the spatial coverage, that the spatial coverage is much less for ERS than for QuickScat and the METOP satellites. There's also a difference between QuickScat and METOP, but their 20-day with averaging window is sufficient. But for ERS, we really have to go to longer windows. And that's what we're currently looking at, how to best do this and how to treat additional data gaps. On the right, you can see a comparison of the biases. This is for different latitudes, averaged over all the longitudes, for both QuickScat and ASCAT, to show that the difference between the instruments is much smaller than the bias itself. So even if you use different instruments, it's quite a consistent signal, and yeah, it's you can also extend the time series using different instruments. But of course, you should always be careful when there's a change in instruments. And then finally, we have a monthly level 4 product. So this is for the users who do not require all this detail. And it's actually based on the same methodology. So we also calculate a bias correction and add it to the monthly mean ERA5 wind fields. So here we have this data set is at a 1/4 degree horizontal grid, and it uses the same scatteron combinations as the hourly data product. And here also ERS and ERS2 will be added this year. And another thing is that the product currently doesn't contain the scalar average monthly wind speed, because we need to extend the methodology for that, but that's also our plan for this year, because users really like to see this variable in the product. And this was my overview of the wind products. Thank you very much for your attention.
Thank you, Rian, for your presentation. Let's see if we have already a few questions. I know we do the Q&A at the end. Yes, sorry about that. It was my fault. Yes, we're gonna thank you very much, Rian, for your presentation, and we'll do a Q&A moment at the end of the 3 presentations about the products, and like that we can all discuss together. So I will introduce you to Fernando Manzano from Puerto del Estado, and he will tell us about the in situ products. The floor is yours.
Good morning for people who is connecting from South America, and good afternoon and good evening for the other people connected from all over the world. I'm going to talk about these in situ products. As you know, in situ means in the place. So the observations are measured just in the place where things are happening. It's a desire for the human beings to observe and record all the environment since ages. In the case of the ocean, the in situ ocean observations are crucial, are very important for understanding the ocean, for sure, to improving the quality of models and forecasts and validating satellite data. And I know that this sentence is a little bit polemic, but I like to say that it's the field of truth that is closest to reality, okay? With this slide, my goal is to you keep in mind that the in situ component, the in situ products, are very different from other products within Copernicus Marine. So only to keep that in mind, in the next slides, I'm going to explain why I consider that this thematic assembly center is very different from all the other thematic assembly centers and model and forecasting centers. The first thing is that we are managing many types of platforms. We have and measuring many things in the ocean. We're measuring profiles with the gliders, with the Argo floats. We're measuring variables through trajectories with the vessels, with the sail drones, measuring sea level with tide gauges, with the moorings, with the buoys. We are measuring also waves. We are measuring even surface currents with HF radars. We are special also because we are formed by many institutions. We are a consortium of 15 institutions, and we have split all the globe in 7 regions. That is the EB, the Med, the Black Sea, the Baltic, the Arctic, the Norway Shelf, and the global one. Why in situ products are different? Because, as I've said before, we are managing many types of platforms. So the files that we are producing are not homogeneous. They cannot be, because we are having time series coming from moorings. We are having profiles. We are having also grids with the HF radars. We have wave spectra also, and we have trajectories. Okay. We have created our own website. I will explain later why, with a specific dashboard for in situ data. And another thing that makes us different is that our files are created by platform, with the exception of the objective analysis and the Easy Cora and Cora, the multi-year ST product, that they are gridded also as other products in Copernicus Marine. This is our products are grouped in 2 different product families. The first one is the multi-year family. Here, the products are updated every 6 months, so twice a year. The scope is global. The quality mode applied is the delay mode, and they focus on one variable. The products that we are providing now for this multi-year family is the BGC carbon for carbon data, one dedicated for biogeochemical data, another one for sea surface height, for sea level, one more for temperature and salinity, another one for objective analysis, one for currents, and one more for waves. And regarding the other family, it's a kind of a mix because it's multi-year and NRT products. What does it mean? It means that we are measuring data in near real time, but after this, we are overwriting when we have available the multi-year data, because we consider that this quality is better than the one for the near real time. So these products, you can consider them more complete, because they reach until today, until a couple of hours ago. They are global and regional. They are applying delay mode when it's multi-year and real time for the last data, and they are containing multiple variables. Here you can see that we have regional products for the 7 regions, and then one more for the global that is including all the others. And then we have the objective analysis and another product for the HF radars and platforms related with the currents. Very important to say that for each of these products, we are providing 2 main documents. This is the PUM, the product user manual, with all the data and all the information about the product, and the quality that is related with the quality, of course, the QUID. And there are other documentation associated that you can query through our website. How to access? The first one is the one that you know, so I'm going to do it fast. It's through the Copernicus Marine Service. You are going to, if you select the in-situ observations, you can filter by the in-situ products, and then if you go to one of them, you click on the map, you're going to see the details of the product. And then from the access, this is what I want to show, is that at the moment, there's only one official way to do it, that it's through the browse, so access directly the files. There are 2 more deprecated services, through an AirDep and through an FTP. So what I wanted to show you is that at the moment, our data, the in situ data, is not available through the My Ocean viewer. We're going to see that at the moment is not still there. The good news is that people behind is working very hard, and we are expecting to have it quite soon. I've been able to see a couple of prototypes, and it looks very nice. So hopefully we are going to have it there very soon. But by now, as I've said before, again, the same options, you can only browse the files. Another access that I wanted to show is through our website. This is marineinsitu.eu. It's a specific website for the in situ thematic assembly center, the in situ tab. Here you can access some services developed by us. One of them, what I consider the jewel of the crown, that is the dashboard. It's a very useful service for data discovery, as I'm going to show you in the next slides. And the other one, it's the providers. For us, for in situ tag center, it's very important to give visibility to providers, because behind all these data, there are many providers doing a bunch of work. So it's important to give them the credits that they are who are providing this data. And then you can access to some statistics about each provider and so on. This is the dashboard. Okay, as I've said, it doesn't matter. Here, this is the dashboard, and on the left you have a menu that allows you to filter by platform type or per variable, or if you only want to take the active stations, or if you want to filter by region, or so on. So it's very, very, very useful to know if we are providing data in some specific area. I'm going to give you some examples. Here is the coast of Argentina. Here we have a couple of moorings. And when you click on one platform, you're going to see some metadata about the platform. And then you have two options. One of them is the download button that is going to link you to all the files available, the last 30 days, the 5 years, or one single file with all the historical data of this platform. Or you have another button, this is the view button, where you can access directly to a chart displaying the information contained within for this platform. In that case, we are measuring the temperature at different levels depth. Another example would be for trajectories. This is the drifters in this area. If we click on this one, we are going to see that it's a drifter buoy. And then you can see also the data. As you can see, the data, the geometry is very different. So in that case, it's a trajectory. So the way we are showing it, it's different. We are showing the trajectory. That's very important for a drifter. And then below, you can see the time series of the atmospheric pressure. It's an example only. And another one, the last one, it's a sea mammal here in the coast of the Antarctic. And you can see also that here the data is different. It's a profile, so you can see the different temperatures in terms of the sea pressure or the depth. Another thing that you can do from the dashboard is to select many stations at the same time to download the data. In that case, using this button, you can download all this data in a CSV text file, which is quite useful also. This is the third method. This is the traditional one, what we have been using until today. In fact, you can use it, but as I've said before, it's deprecated, but it's still working. Here you can access through an FTP, the NRT family and the multi-year family. You're going to see something like this. At the moment, we have two data sets, one with the underscore prep, that it's a previous version, because in November 23 release, we released a new format, and then the files are different. slightly different. So we are providing at the moment the two options, the old format and the new one. And here inside, you're going to see some index files and then a latest, a monthly, and history file. That is the same as I show in the show before. The latest has one subfolder per each day, and inside one file per platform. Regarding the monthly, you have first a subfolder per platform type, inside one subfolder per month, and inside one file per platform and month. And in the history, you have again the same structure, first by platform type, and then one single file for all the data of one platform. And here I'm going to show you the in situ files content a little bit, only to show it's quite easy, in fact, because here is an index latest. This is the index files I mentioned in the previous slide. Here you have some header and then some attributes that we are declaring here in the first row, and then you're going to have one row per each file contained inside. So that way, with this metadata, that way you can automatically, with a script or whatever, you can see what are you going to find inside. And then if you want to check and to download all the files for temperature, for instance, then you can see the last field of each row to know if this file is going to contain temperature or not. It's quite easy. Only one comment related with the November 23 release is now is more aligned with the CF conventions, because we have implemented the discrete sampling geometries. And an example, for instance, for time series, now latitude and longitude that previously depends on time, now because it's the concept of a mooring needs to be in a fixed position, now are scalar. It's only an example of why are we decided to use the CF conventions, discrete sampling geometries. And that's all. In case you have any questions later in the questions and answers section. I can't hear you, Andrea, and I don't know if it's only me.
Oh.
Now it's
Sorry.
okay.
I was muted.
Okay.
I was saying this was all for the in situ for the moment, in situ products, and now we're going to jump into the model products, and later on, yes, we will answer all your questions. Thank you, Fernando. And hi, Valentina. She will tell you about the model products from the Copernicus Marine Service, whenever you want.
Okay. 1 second. Okay, perfect. So hello, everyone. I'm very pleased to be here. So my name is Valentina Junta. I'm a product analyst at Mercator Ocean International. And today I'm going to present some of the ocean models products that are being offered by Copernicus Marine Service. So as Andrea said before, there are more than 250 products that you can find in the catalog of Copernicus Marine Service. Within those products, there are 93 ocean model products, and I'm going to talk about them today. So these products offer information about different variables that help us to understand and to monitor the ocean. So they offer information regarding what we call the blue ocean. That means all the variables that describe the physical state of the ocean, such as temperature, waves, salinity, velocity, and sea surface height. These products also offer information regarding the green ocean that describe the biological and biochemical state of the ocean, such as chlorophyll, light attenuation, pH, oxygen, nutrients, and many other variables as well. And also, these model products can offer information regarding the white ocean. That means all the variables related to the sea ice, such as sea ice velocity, sea ice concentration, sea ice thickness, albedo, and snow. So as Andrea showed before, there are different data sources available through Copernicus Marine. Today, I'm going to focus only on the model data. You can find different temporal coverage for these products from multi-year, real-time, and it is currently offered forecasts up to 10 days. And for this presentation, we are going to focus only on global products. So as my other colleagues described before, the satellite and in-situ observation data, just to mention that we use model data as a 3D numerical representation of the ocean, which assimilates what we call real data. That means that all the satellite data that is available and the in-situ observation data available from different network and platform, they are used for assimilation of these model products. So this is just to give you an overview of the number of users that we have for South America and Central America, and the top products that are currently used by many of the users. So today I'm going to focus only on the two top model products. So one is the global analysis and forecast, and then the other one is the global reanalysis. But before explaining these products, I would like to have to give you a short overview about the different characteristics of the ocean model products. So as I said before, this model offers data about the, so we have three different types of models. So we have one for the physical part of the ocean, then we have one model for the biogeochemical part of the ocean, and then another one for waves. We can divide this model in three different categories. So first we have reanalysis products, which ocean reanalysis offers the modeling the state of the ocean over a long period of time, that it can be several years, while correcting with the best available past observations coming from satellites and from in situ data as well. So these reanalysis that offer an idea of what's happening in the past, and that it can be used for computing, for example, long-term trends. We also offer something that is called ensemble reanalysis, which considers multiple simulations to account for uncertainty. So you can find those two types of reanalysis on the catalog. Then we have what we call hindcast, which is an assessment of the past state of the ocean variables made using numerical models. And for hindcast, you find two different types. One that is without data simulation, that is called a simulation. And then the other one with data simulation, that is what we call analysis, which is a snapshot of the state of the ocean at a given time. And for the analysis, you can find best analysis or the near real-time analysis, and the difference between both, it depends on the number of observations available for assimilation. But also, you can find the forecast, which is an assessment of the future state of the ocean variables, made also using numerical models. And the first type of this forecast is what we call nowcast. And in Copernicus Marine, you can find forecasts up to 10 days. So now we can have a look at the different products. So for the global analysis and forecast, as I said before we have three different types, one for physics, one for waves, and another one for biogeochemistry. So for physics, it has a resolution of 1/12 degree. It can be, the data can be hourly, daily, and monthly means. The variables that you can find for these products are temperature, salinity currents, sea level, mixed layer depths, and many others. It offers information from the surface up to 5,500 meters in 50 vertical levels. And it offers data from 2 years in the past at up to 10 days of forecast. Then we have the global model for waves, which has the same spatial resolution as the physics. And it provides hourly data and information about wave parameters from the total spectrum, such as significant wave height, period, direction, and also information about the primary and secondary swell waves. Also offers information from 2021 up to the present and 10 days forecast. And for the biogeochemistry, it has a lower resolution, which is 1 a quarter degree resolution. And the temporal resolution, it can be daily and monthly means, and it has information about chlorophyll, nitrate, phosphate, many other nutrients, oxygen, pH, and many other variables as well. It has also 50 vertical levels from the surface up to 5,700 meters, and also offers 10 days forecast. And then, as I said before, you can also find the reanalysis product, which covers a longer time period, and they can be used for studying trends. So we have two different global reanalysis products. One that is ocean physics with a 1/12 degree resolution, daily and monthly means, and offers information about temperature, salinity currents, sea level, mixed layer depth, and ice parameters. It has 50 vertical levels, and it covers basically from the altimetry era from 1993 to 2023. And it's based on the global ocean model that I presented before. And then we have another product, which is the Ocean Ensemble Physics, that it has a lower resolution, a quarter degree resolution. And it has daily and monthly means data sets. And then you can find variables such as temperature, salinity currents, sea levels, well, and many others. It has more vertical levels. It has 75. Also covers data from 1993, but up to December 2022. And the difference is that it uses 4 types of reanalysis to create this ensemble product. This multimodal ensemble approach allows uncertainties or error bars in the ocean state, so accounts for uncertainties. And I think, yes, that is all from my side. Thank you.
Thank you, Valentina, for your presentation. And yeah, now there's a few questions for all 3 of you, Rian, Fernando, and Valentina, I think. So the first one is, I have to say, it's actually more for me. It's more general question. It's about the slides and if the recordings will be available. Yes, they will. Well, I mean, if our speakers agree with, we can share the slides with you, and the recordings will be available as well. Yes, and so as a second one, I think it is for you, Fernando, because it was during your presentation. If
Yes.
it makes sense, yes. Are there
In fact,
documented APIs available?
I forgot to say that. In 10 minutes, it's very difficult to say everything. But yes, I was going to say that there is a quite recent new API. This, I don't know if you've heard about that, is the Copernicus Marine Toolbox. It's a very powerful new tool API, because it's not only a command line interface. It's in addition a library, a Python library that you can use within your scripts. And I guess that tomorrow during the practical session, they are going to show more about that. But yes, of course, that's
Yeah, they might mention it a little bit more. Mm-hmm.
Mm-hmm.
Yeah, that's it. It's a recent update on how to access the data, and so some of the products are. So the transition is still taking place until the end of March, but yes, as you said, it is quite promising. So the second one, I think it's still for you, Fernando. BG carbon equals POC. If so, from where are calibration points taken? Is it known that POC characteristics differ from subtropical to
It's
subarctic
too
regions?
specific. As
Too
I
specific.
said, our products are very heterogeneous within the in-situ tag, but it would be my pleasure to transmit this question to the carbon people that it's behind, and I'm going to ask them to know, but it's very specific. I'm sorry,
Sure.
I cannot answer. Yeah.
No, don't worry. Yeah, and okay. I was wondering about whether there are additional in-situ data collection done in the South Atlantic or Caribbean Sea. I know some is done by the US-based agencies.
Yeah, for sure. We have We have data all around the world. The dashboard, the slide that I show, was focused on the South America, but because of this webinar. But for sure, if you zoom out, you're going to see that we have data all around the world, including the South Atlantic, the Caribbean Sea, and all the world. But if you detect that there is some area without data in the dashboard, so it's not included in the in situ tag, but you know that there's data there, then you can notify this, because we are interested also, and we are going to make an effort to integrate this data. So we would appreciate a lot this kind of information.
To contact the
Yeah.
in situ. Okay, and they contact you through the Copernicus Marine Service website. They will get to the
That's
in
correct.
situ thematic center. Great. For the global analysis and forecast, I think it is for Valentina. For dates previous to 2020, 2021, does it exist any equivalent, and where can we find it?
So the thing is that the data for ocean models, the ones that is provided is up to 2 years before the current date, but it doesn't mean that the previous data has been erased. So it's not there. But if you want to access to archive forecasts, for example, you can always contact the user support team, that they can help you to find a way to access that data. But because of the storage, we only provide up to 2 years in the past.
So about wave data.
Yeah, I think it's the same kind of question. So it's about the period. If you want to access to archive data, you can contact the user support. And I think there are like a few articles also about how to access the archive forecast on the help center. Yeah.
Very probably. So about the biogeochemistry resolution, why 1/4 compared to the other products with 1/12 resolution? Was it Valentina?
Yeah, so I think this question, I just am going to give you my opinion. Maybe it's not the technical answer that you might expect, but I think the physical models are the ones that has been developed for a longer time, and they are more advanced than biogeochemistry models. So right now there is a very huge effort behind, and we are working on improving a lot the data that we are offering for the green ocean regarding ocean models. But so far, the resolution is lower in comparison to the wave and physics models.
Okay. So is it, for example, I mean, I don't know if you know, but is it because it's harder to get like bio data, and so to then assimilate it in the models, or?
So I think it has to be a little bit with the data that you assimilate, the ability of the data. I think now with the Arco BGC profilers, so we have more data to assimilate, but also it has to be with to really account for all the processes that are happening in the ocean, and to try to really model that. Yeah, exactly.
Exactly. Okay. It involves much more, I guess, than just temperature, salinity, or see. Next one. Wow, we have a lot of questions. I hope you guys have time. Where can I access the wind velocity information? Maybe for you, Rian.
Yeah, I think so. The wind velocity or wind speed is in actually all the products except for the monthly product, where we will add it later this year. So it's both in the level 3 from the spectrometer observations, and also in the level 4 hourly products, where it's a combination of ECMWF, winds, and bias corrected with spectrometer observations.
Thank you. And would we need to contact if we find some unrealistic values in some Copernicus data sets? Maybe the user support as well. If there's something that you find that doesn't make sense to you, please contact us. We are interested to know if something is not right as well. So please do. Thank you. Question to Fernando. Are there all meteorological towers available? Are there at all meteorological towers available in EC2 database? if towers are even
meteorological
used.
towers, but okay, it's a tricky question because it's supposed that we are not adding wind and meteorological data because we are more focused on the ocean.
Yeah.
But it's true that at the same time, wind it's very important for waves and for other phenomena within the ocean. So what we are doing is once if we have any platform that it's measuring some ocean variable, but at the same time is measuring also wind, we are providing this data also. We are not applying quality control over this data, but we are providing it as the provider is having these measurements. So, yeah.
Okay.
So in some cases would be the answer.
I see. And again to Valentina, is there a wave reanalysis product? And also, is there any wave spectra data available in the global analysis?
So thank you for that question because I didn't present it, but there is a reanalysis product for wave. And if I'm not mistaken, it has a resolution of 0.2 degrees. And you can find it in the catalog. Yes, there is one they have plenty of variable related to the wave spectra. So that is a good product for that.
And again, for you, about the global analysis, are the physics and waves models working coupled? Is there interactions between them?
So regarding the technical part of the products, I will suggest to go and check the documentation, the product user manual. It has everything related if they are coupled or not, or the interaction between the different models. So you can check the product user manual that is associated to the product, and also the quality information document if you want to learn more about the validation of the model as well. So those two documents are very helpful to try to understand how the model works a little bit better.
Thank you. For Rian, is there a wind bias corrected in Euro 5 product?
Yes, this is actually the level 4 multi-year product. The thing with the product, there's a little issue with the product in the catalog at the moment because it in the product information it doesn't show the entire time series, but and also not in the viewer. But if you want to download data, you can actually download the entire time series. And this will also be fixed soon, but it has to do with the large amount of files we have for this product. So it covers the entire period for ERA 5 now from 1999 until 4 months before present.
Another one for you, Rian. I think after HasCat, there is some wind data available. Is there some?
Yes, I'm not sure what the question is here, but one of the HasCat instruments, the one on MetUp A, has ended in end of 2021, but there's still 2 other HasCat instruments which are currently still operational, HasCat B and C. In addition to that, there's also 3 Chinese instruments on the Haiyang satellites that we have currently. And we will also add OceanSat 3 in later this year.
Okay, quite some improvements to come.
There's a lot of data available at the moment. Yeah,
yes, but yeah,
golden age.
I'm sure there's a lot already. I'm not sure who this one would be to, but model. Do you have an idea of about at what moment in 2000 or the 2023 post-process ocean model data will be available?
So to check for updates of all new products, not only ocean model, but also satellites, in situ and services, I will suggest to have an eye on the product roadmap that is available on the website. We put all the information there about the updates. Every time that we have a release, we put information also about the updates, but also about what is coming in the following month. So just, I don't have the date for that, but just keep an eye on the product roadmap.
Exactly. Thank you. And we do still have some questions, but we will have to continue with our session. So we thank you for your questions. We will collect them, and if our speakers are okay with it, we will forward it to them and try to get their answers and share it with you guys. Thank you, all three of you, for representing the product and telling us what we can find in the Copernicus Marine Service. So I hope you're still here with us after this short break. To reset, we'll invite our next speakers now. I'll invite Bárbara Franco from the Centro de Investigaciones del Mar y la Atmósfera in Buenos Aires. Hi, Bárbara.
Yes.
She will present her project, Climate Change Impacts on Fisheries and Conservation on Marine Species. Welcome, Bárbara, and the floor is yours whenever you want.
Okay, thank you for the presentation and thank you for the invitation from Copernicus. Well, my currently main field of work is the climate change impacts on fisheries and conservation of marine species. And in this case, on a second. Okay. In this case, I will be talking about a work in which we study the subsurface ocean warming hotspots and potential impacts on marine species, the Southwest South Atlantic Ocean case study. Well, what was the main question of our study? In the Southwest South Atlantic Ocean, this is our study region in this case, in which we study the continental shelf of Brazil, Uruguay, and Argentina, and also the open ocean waters. Okay, well. Then, in this study area, strong ocean surface warming or hotspots regions have been observed in the past decades. However, there was no knowledge about the signature of ocean hotspots below the surface and the potential effects of ocean warming on marine biota. Then our objectives were provide initial evidence of how the hotspots of this study region extend in the water column, in particular at mid-water and bottom layers, where two marine species, the green turtle and the Patagonian scallop, inhabit. And for this, we compare 15 years of Copernicus Armor 3D high-resolution 3D temperatures reprocessed from combined satellite and in-situ observations with high-resolution Mercator ocean analysis. And then we use location of green turtle and Patagonian scallop to discuss the potential impacts of the ocean warming on these species in terms of geographic distribution, technological shifts, and thermal tolerance. And well, these were our main results in these left panels. We can see the glorious temperature trend during these 15 years. In this case, near the 20 meters depth. Here near the 50 meters depth, and here near the 100 meters depth of the water column. No? Then in these red areas, we can see the main regions of the warming or hotspots regions in our study area. And in the left panels, we can see the same results for the Armor 3D Copernicus products. And we can see very similar results. Well, for the green turtle data and distribution modeling, to explore the potential changes in the green turtle oyster distribution, driving mainly by the warming of inner shelf waters, we use satellite tracking of juveniles during this period of 2008 to 2011, and then we developed maximum entropy species distribution modeling to identify the potential distribution of the green turtle in relation to two predictor variables, the sea surface temperature or SST and the bathymetry. In this case, the SST is derived from Glorious 12 data from, for the same period. And our modeling exercise shows that the potential distribution of these species in our study region is driven by the SST and the bathymetry, so the contribution of SST changes during different seasons. And for instance, in these panels, you can see the green sea turtle monthly habitat suitability. And then, for instance, in the red colors areas, we can see the high habitat suitability for these species in our study. Okay. And in this figure, you can see the glorious temperature trend for the 15 years near the 100 meters depth. And then we can see in these red areas were allocated at deep layers. We can see for the first time were allocated the main hot spots or warming areas in the ocean. And then what are the main contributions from Copernicus dataset for our study? Well, I think the main contribution was obtained from the high resolution Mercator Ocean modeling, because in this area we have a really lack of long-term monitoring programs to address the impacts of climate change on marine biota. And then our results in this work could provide the first effort to call the attention of stakeholders and decision makers on marine conservation and fishery management, toward better management strategies in the context of climate change. And then in this study area and all the South Atlantic Ocean, we need yeah, from the many high resolution ocean modeling data set to make a long-term monitoring studies, and relate with the ecosystems of our region. Well, this is my main key message for this presentation.
Thank you, Barbara. Thank you for your presentation. Let's see if we have, I think we do have a few questions already. Yeah, we have one question for you.
Okay.
So let's see if we can have it on the screen. And that way it's easier for us to see the question. So the first of the question is the wind stress, the one that you use to force the oceanic model of Mercator, reanalysis and forecast. Where can I access? So where can I access the wind stress the data?
Okay, the wind stress data is not separate from, it's included in the reanalysis Glory's 12 dataset product of reanalysis from Mercator Ocean
So it's all,
model.
so
It's
in the
not,
reanalysis and
it's
forecast.
included, no, the model.
Great. No, I think that's all for questions for you for the moment. We can give maybe 1-2 seconds to see if someone else has other questions. But anyways, that's very interesting. Thanks a lot for your presentation.
Oh, thank you.
And let's invite our next speaker, who's Gonzalo Dordenbencoa. Hi, Gonzalo.
Hi,
From the
Andrea.
Departamento de Oceanografía Biológica, Centro de Investigación Científica y de Educación Superior de Ensenada, who's gonna present to you the Copernicus Marine satellite-driven data as a useful tool to establish the relationships between larval fish distribution and density and the oceanographic of the Gulf of Mexico's deepwater region. The floor is yours. Welcome.
Okay.
And thank you very much.
Yeah, thank you. Thank you for the team for this invitation. So I'm delighted to be here. I think I need access to be able to move around the presentation. So 1 second, please. Yeah, I think we're on it. Okay. So, well, thanks again. My name is Gonzalo Alden, and as Andrea said, I'm talking on behalf of the Center for Scientific Research and Superior Studies of Ensenada. And I want to showcase a couple of studies we did in the past years where we used some of the Copernicus Marine satellite data to relate it with the densities and also the distribution of some larvae from several species in the deepwater region of the Gulf of Mexico. But in order to do this, we need to settle some bases. So first, I need to say that marine fishes have a complex life history and cycles, and each developmental stage may have many habitat, may occupy many different habitats with distinct environmental conditions. So for example, as you can see in the figure on the left, for example, in case of neritic adults, which are the ones that inhabit the continental shelf, we might be able to find larvae in the epipelagic waters between 0 and 200 meters. In contrast, for example, for oceanic adults, which are beyond the continental shelf, we can find some of them maybe in oceanic epipelagic waters, as I mentioned, but others are from mesopelagic waters, which go from 200 to 1,000 meters. These are the adults, but in contrast, the larvae generally stay in the first 200 meters. And besides that, we also see that they have different life histories and also the way they reproduce. For example, in neritic species, the ones on the left, such as the bullet tunas, they have a seasonal reproduction in comparison, for example, with mesopelagic species with reproduce year-round, or the hatching changes between like surface or up depth. The number of eggs can go from many eggs to a few of them, and also with a contrasting larval stage duration from a fast duration from 15 to 30 days to a more slower in the case of the lantern fishes, which are the myctophids. Also, to settle on the basics, I would like to say that the Gulf of Mexico circulation is strongly influencing the loop current, as you can see here on the map. It has different degrees of intrusion into the Gulf. And from the loop current, sometimes there are mesoscale structures, such as the ones that are marked in red, what we call anticyclonic eddies that can detach and travel westward in the Gulf of Mexico, and usually have a circulation that is a clockwise circulation, and you can identify these structures because they are above the sea surface of the sea level. In contrast, for example, with the structures that are in blue, which are the cyclonic eddies that are counterclockwise, and you can identify because they are below the sea surface level, and they have a rise of the pycnoclane, providing having like a better primary production, and also other structures in the Gulf, such as riverine flows, providing offshore transport or upwellings near the coast. So now that we have settled the basis, I would like to tell of one of the papers that it's called Larval Fish Assemblages of Myctophids in the Deepwater region of the Southern Gulf of Mexico, linked to oceanographic conditions. There are some images that you can see of the myctophids, adult myctophids. And the reason why we worked with myctophids in this case study is because it's one of the families with a higher biomass among mesopelagic species and comprises 75% of the oceanic fish biomass. It's also very diverse and presents a wide global distribution. And it can be used as a biogeographical indicator and tracer of oceanographic processes. So larval fish assemblages are defined as a group of taxa present at a specific place and time, and we need to know this in order to see what's our goal in this project, which was to characterize the structure of myctophids, larval assemblages in the Southern Gulf of Mexico relative to adult spanning and surface circulation. So we sampled the entire deepwater region of the Mexican Economic Exclusive Zone of the Gulf of Mexico with 57 stations, which we can consider our assemblages. And it was between the months of August and September of 2015. With this, we would like to know where are these assemblages in the ocean, right, in the Gulf of Mexico. So we've used the sea surface height to characterize mesoscale structures during the sampling period. And as you can see here the loop current, an anticyclonic eddy that detached from the loop current in that period of time that is very close to some stations. And we saw another anticyclonic eddy that previously detached in May that is in contact or present where some of the stations we sampled. So the reason why we did this is because we would like to obtain these assemblages, and to do that we use clusters obtained from Barak-Cortez similarity matrices. And as you can see on the map on your right-hand side of the presentation, we can see like a blue assemblage, a very specific region, which is the Western Gulf of Mexico. And also we can see a yellow assemblages, a smaller one, which was near the Olympus anticyclonic eddy. And also we can see some other assemblages in green and in red. All of these points, each color represents that the assemblages have, between them, they have a 60% or more of similarity. So what we were able to discuss about this is that the Western Gulf assemblage, which is the one in blue, might suggest that there are some spawning grounds and seasonality of a similar adult community of myctophids or lanternfishes. In the yellow assemblage, the loop current assemblages might be due to high retention capacity of the area due to that the Olympus anticyclonic eddy is very close. And also we saw that the green and red assemblages is dispersed along the Gulf of Mexico, which might reflect that myctophids are cosmopolitan. So our conclusion in this part is that the lack of relationship with oceanographic variables, such as the sea surface height, might indicate that myctophid larval assemblages mainly depend on adult distribution on spanning areas. Next, I would like to talk another paper which talks more about relating the densities of several species with contrasting life histories in function of oceanographic variables in the deepwater region of the southern Gulf of Mexico. So the aim of this study was to describe the larval distribution and density relative to environmental conditions. So first of all, in this case, we used 12 oceanographic cruises, also in the deepwater region of the Mexican Economic Exclusive Zone of the Gulf of Mexico. And we were able to divide it these cruises in 2 seasons, spring and summer, and late summer and autumn, thanks to these satellite variables such as wind speed, surface chlorophyll A, where we saw that from April to July, the speeds or the concentration was higher, or for example, the sea surface temperature or the sea surface height, which was lower during season 1 in comparison to season 2 on August and October. So this was one of the parts to settle the basis in order to answer our questions. And we did a selection of several species according to ontogenic, commercial, and economic importance. Although for the sake of the little time we have, I'm going to focus only in one group, which is the frigate and bullet tunas, which I think is better known among at least biological oceanographers. So we can see that during season 1, we see one specific distribution and also one specific density in contrast with season 2. So we would like to see what are the reasons, why are the reasons that there's such a difference in the density. So in order to establish the relationship between the species and larval densities and the oceanographic variables obtained from Copernicus Marine Service, we used generalized additive models. So some of the variables we used was sea surface temperature in order to identify mesoscale structures, as I mentioned before, and sea surface height. And also we used surface chlorophyll A concentration as a food proxy, and also surface wind speed as an indicator of turbulence in the surface, and also can be used as a food proxy indicator of feeding success. To establish this relationship, we use GAMS, which is just an extension of generalized linear models, but are non-parametric and non-linear. And here are some of the results. In the red figures represent the season 1 from April to July, and the ones in blue represent the season 2 from August to October. And first of all, in the yellow box, we see that there's a positive relationship between the sea surface temperature and the density in both cases. However, we see a different behavior in this relationship. Since we're seeing, or we can see that there's we can find higher density at greater temperatures. This might be because it provides a higher growth rate. Also, when we see the box in green, we see a positive but non-linear relationship in both cases, and we find that the greater densities were in areas where the surface chlorophyll concentration was higher, at least in the deep water region. And lastly, but not least, we see a different behavior of our figures where we didn't see a positive relationship in any of the cases. But what we are able to see is that there's actually the greatest densities of larvae and also observations, where you can see here at the bottom, were in average wind speeds from the whole range we had. And this might be because adequate wind speeds may increase the feeding success of the larvae. So from this presentation, what we can conclude about the pros of using this information is that satellite data allowed us to identify mesoscale features in the Gulf of Mexico deepwater region. That satellite data in conjunction with other variables analysis allowed us to define that myctophid larvae assemblages are mainly influenced by adult distribution and spanning regions rather than by the oceanography of the Gulf of Mexico. And we were able to identify two main seasons in the Gulf of Mexico deep waters by comparing satellites, sea surface temperature, height, chlorophyll, and wind speed. And finally, that the identified variability in the oceanographic conditions between seasons showed a change in the relationship between them and the larval densities of bullet and frigate tunas. So that will be all for me, and thank you very much.
Thank you very much, Gonzalo, for your presentation.
Yeah.
That was very complete. A lot of work on your
I
side.
tried my best.
Thanks a lot. I think there were no questions during your presentation. I think people were so focused on everything you had to say.
I know it was fast, but
No
I just would like to say that everyone can contact me. I guess my email is there, so feel free to contact me.
Sure,
we can
yeah.
discuss
If you're happy
question.
that we can share your contact, for sure, it's something
my pleasure. My pleasure.
Perfect. And just to remind everyone that the recordings will be available in the events page, and also whatever questions that might come in the meanwhile, we will try to answer them, ask our speakers to answer them, and then make the answers available to you. I think there's one question that came in the meanwhile. So in the upwelling regions such as Peru, we have a lot of myctophids. I think it's more a comment.
Oh yeah.
Are you planning to do a study maybe somewhere else than in the?
I would love to. I mean, I've been working all this time in the Gulf of Mexico. However, now I'm in Spain. But yeah, I would love to work in the Pacific Ocean. And yeah, myctophids are
There's a
everywhere.
possibility
As
there.
we usually say in our lab, like myctophids are the cockroaches of the sea. So it's not a surprise that they are there.
Okay, so they are everywhere. Is that what you mean? Or
Yeah, they are everywhere.
okay, good. So you can basically travel.
Yeah, I would love to.
Okay, I think that's all questions for you. Thank you very
Okay,
much
thank you
for
very much,
sharing your
Andrea.
project. And now we're going to have our last use case of the day. We'll have Paulo Nobre from the Instituto Nacional de Pesquisas Espaciais in Brazil. And he will tell us about the Copernican data for monitoring oil spill on the ocean at the ENPE, the 2019 Northeast Brazil oil spill and scenarios. Hi, Paulo. Welcome. I was going to speak Portuguese now. Bem-vindo.
Yeah.
Welcome, and the floor is yours whenever you want.
Thank you, Andrea. And it's a pleasure to be with you and with the Copernicus Marine Services. And today I speaking in behalf of my institute, the National Institute for Space Research. And I would like to report on two aspects of the use of the intensive use of Copernicus data at INPE, which are the application in two cases. One is there's a missing slide here. One is the surface Lagrangian model for use of current for Lagrangian model simulation, and the other is the use of Copernicus Ocean Mercator data for initializing our forecast. And here is the motivation for this. The first one, the tracking oil spills in 2019, we suffered a huge, I think the largest contamination by oil spill we ever known, in the tropics at least, that reached Brazil more than 2,000 kilometers of beaches oiled and 5 tons of oil. It was a huge impact, and we were caught by surprise. We didn't know where the oil came from, how much oil was to come next day and next day. And after a while, we published this paper for analyzing, and there were a few papers published trying to identify how it happened. And here I have two figures that exemplify the efforts to to learn what happened there. Over here, we have all these points in which we had done simulations of oil trajectories of dispersion, trying to mimic the distribution. And you see the distribution here comes all the way from the northeast to the southeast. And there was only one possibility here, that the oil was spilled over the South Atlantic current. And after the bifurcation, it will go north and south in different times. And for all this analysis, we use the Mercator current, preteritus, the analysis. And the points that best simulated the distribution, the temporal and spatial distribution of the oil, was cited among this small rectangle here. And this is one of the simulations of the dispersion. And over here, we did a vertical cross-section at this time. And you see that the oil was mostly being carried underwater, under the surface, such that all this information, all these satellite images from Sentinel-1 and 2 that were available for us during the time. Here is the density of the Sentinel star images, the radar images over the region, and showed no oil. So the satellite imagery would show even the day before a big amount of oil reached the beach, we would not see it because it came underwater. And I must say this, you see this big bar here, it was Copernicus, or the Copernicus response to our need, and the Sentinel data was increased substantially during the next month, trying to see if we could observe from space what was going on. And eventually it was determined a few ships were in the region. So what we then started doing is that whenever oil would appear on the beach, we would do a backward trajectory using Mercator ocean current analysis and the Lagrangian model, the Parsons models, to backward where that oil could have come from, and cross that information with tankers that were at that time close to the path which the oil would have received passed by. So this is one case in across the year 1st January 2022. The oil arrived here in Paraíba Beach, and then we back trajectory it. The colors are time after this point here, and these are the ships. To exercise, if we didn't see it on the spot, whose ship could have been associated with some kind of spill. And this is one photograph of the people collecting oil on the beach at that day. And another kind of use of the Mercator currents are the forecasts. So this is another example in which we had one of the oil platforms reporting a spill to IBAMA, our agency that monitors protect the natural resources in Brazil. And IBAMA contacted us at INPE and said, we had a report that such amount of oil was spilled on the water. And we did the forecast. We used the Mercator forecast for the next 10 days and used Oscar oil dispersion model to predict where that amount of oil would go if it would reach some beaches, and did not. And so with that in mind, we then developed in Brazil a system to, we are still developing this system called SysMon, monitoring, predicting oil spills over in the ocean, and to avoid that such things happen in the future. Now I will in the next few slides will show how are we using Mercator analysis to initialize our coupled system. And here is a diagram how we used to do our seasonal forecast with the Brazilian Earth System model. We would use GFS from NOAA atmospheric analysis and force MON6 and obtain here an ocean analysis, a poor man's analysis without a data simulation, and GFS atmospheric uncoupled initial conditions and run our forecast. After we start using Copernicus, in this case the Mercator Ocean, we started still using GFS atmospheric initial state and read initialized Mercator real-time current, temperature, salinity, sea surface height, and CI to do a coupled initialization, ocean and atmosphere coupled initialization. And then from this coupled initial state, atmos, ocean, and ice coupled, we are now doing our seasonal forecast. And there you just saw a few examples of what it means. So imagine this is the Gulf Stream region here on the upper left panel. This is temperature, sea surface temperature from Mercator. And using the simulation of the Mercator data, we had this initial state here in the center. And again, the first line, using our previous method of spin-up model, we would have this initial state. And you can see how the spatial gradients are much better captured by assimilating Mercator data than our previous method. Here is over the Kuroshio region, also in which we have strong horizontal gradients. Here is the Mercator data, and this is initialization of our model with Mercator data, and here is our previous method. So immediately we saw that we had a more realistic initial state when using assimilating. And this is another case for Southeastern South America, the original field, and how our initial condition would show when assimilating, showing that we could capture the spatial variability or the spatial variation, the gradients of temperature. And now I have just two examples of actual forecast. This is Mercator analysis for November 2023 for the equatorial undercurrent. This is depth, latitude cross-section, and we see here the core of the EUC, the equatorial undercurrent, in November. And this is a November forecast from BESM, from our model, initialized 30 days before from Mercator, in the way I showed it before, showing that the model did a very, very nice representation, actual 30 days forecast, and we run our forecast all the way for 6 months. It's our seasonal forecast. Here we just did this time slide to present, to exemplify. And here, this is my last slide, just to show a global product. This is one January 2024 SST. This is actual analysis. And this is the November 23 forecast for January. And we Of course, they are not identical, but we could see that our model could represent the ENSO, the warm Central Pacific, prolonged the South Atlantic convergence zone here. In other words, it's a demonstration of how we are actually using the Mercator ocean products and also the Copernicus, the satellite products in our both operations and research. And just to say, it is a great product and a great service worldwide. And I have only words of honor to compliment Copernicus and the European Union for these wonderful products that you offer to the community and mankind. Thank you.
Thank you very much, Paolo, for your words and for sharing your projects with us. Let's see if we have already a few questions for you. Last time I checked, we did not. Just to remind everyone, this is the last chance for you to ask the questions you might have to our speakers while they're still here. Maybe we can leave one second more to see if there's any question coming in. I was wondering if Paulo, you tried this study with to study the oil spill. Are you planning to use, for example, apply the Copernicus and the Mercator's model into another type of study, other spill, or any other particle drifting kind of study, maybe plastics or something like that?
Yes, yes. As I mentioned, this project that we are undergoing, we are counting with Copernicus as a reality check all the products, both satellites and ocean products, in order that we can track several kinds of hazards that come from the ocean. And one thing, just a few minutes, but we can see pollution arriving, say, in Fernando de Noronha, that can come from very far away, and like the African coast, and that the Copernicus and Mercator products are helpful to monitor that.
Yeah, I guess so. So there's a question that came in. I don't know if you had experience with this, but someone is asking, how can we contact the Copernicus to obtain more images when an oil spill happens? Well, as far as I know, we don't provide on demand, but if you do have a question, you can always send it to us, and maybe we can direct you to the person who could provide the satellite data. Paulo, if you want to add in something on that, on your experience.
Yes, in fact, we use the data that Sentinel data that is available. But the oil spill that reached Brazil was such an enormous disaster that Copernicus voluntarily changed after to engage in the same effort
so it was a
to try, as a response to the damage.
Okay. So I guess when it is maybe something like this, such in a big dimension, it could be done. But otherwise, contact us anyway, and we will give you an answer for sure on that. There's another question here. How to get the NetCDF data, current and winds for Central America. So tomorrow we will have a bit more of a demonstration on how to access data and visualize data. And I'm not sure we're gonna show currents and winds, for example. I think it's gonna be more temperature, but in the same way, you can access the Copernicus Marine website, and in the access data section, you will able to scroll down the catalog and find or try to look for the data you're looking for, and also the region and the type of data, so by satellite or model or in situ data. So I invite you to explore the website and see if there's if you can find what you're looking for. If not, let us know, and Cedric will tell us a bit more on how to contact the user support, so you will know about that. Let's see if there's any other question for you, Paulo. Which of the product that we could use to study ocean physical parameters, specifically for projects in West Africa? Okay, it's a bit more general, but maybe you can jump in on that one.
Yeah, I would say like we do is
Yeah,
to
exactly,
get the
global.
actual and run regional models. And that's what one thing that we are doing is will be running ocean regional models with much higher resolution to attend specific questions.
Mm. Okay. And question, your institute, so INPE, has already begun studying oil spills, but using data from AI models. Have you tried already something like artificial intelligence models?
Yes, this is this corridors and the central field next development is to develop artificial intelligence models to predict several things from ocean ship detection to oil detection and prediction. The work that ECMWF, for instance, is doing in terms of using artificial intelligence for actual weather forecasting and climate forecasting is something that we must pay attention to.
Okay. Thank you. And one last question. It's in Spanish, but it means how long did it take you to localize the origin of the spill? So the ship, the vessel that was the one who actually spilled the oil in your study in 2019.
We kept receiving oil. The oil was spilled in August. Late August was the first, and we kept receiving oil up until December. It was a big mystery. It was a big mystery. We didn't know it was a sunk ship liberating continuously or not. But eventually it was not. It was detected that was current time oil because it had synthetic in it. So an old ship would not have that. And we took a few months to discover because it was not localized immediately, and the oil came underwater. So, but it took some 6 months before we could spot a few ships that were in the region at the time necessary for the oil to arrive to the ship. So it took. We hope that will never happen again, but if it does, we must be prepared to be on stop. And then we are looking for the next Sentinel and the other satellites.
Okay. So in this case, would a bigger resolution or better resolution help in this case in terms of satellite data, for example, or what could have helped? I don't know, maybe find the origin vessel quicker, if you can say.
Yes, we need to have a much finer temporal resolution satellite imagery. And one of the parts of our project is to develop a constellation of satellites that will be orbiting in the region for this specific product. And we hope that one day we'll be able to sit with Sentinel people and show what we are planning in INPE. INPE is primarily Earth's satellite. Our satellites are projected, built, and operated by INPE. So yeah, the temporal resolution, more than the horizontal resolution, today's satellite version is necessary if we want to have a real-time monitoring system.
Real-time. Okay. Thank you very much, Paulo, for your presentation, for being here. And thank you all three of you, Barbara, Gonzalo, and Paulo. We will have now our last speaker. He's Cedric Jordan. He's going to tell us about how you can access the user support, the help center, and yes, basically what you need to access the Copernicus Marine Service. Hi, Cedric. Welcome. Whenever you want.
Hello, Andrea. Hello, everyone. So I'm Cedric Jordan from Market Ocean, and I manage the user support team of the Copernicus Marine Service. So you should see my screen and the Copernicus Marine website. I'm going to give you a short presentation of the user corner. It's available at the top menu. User corner here. I click on it. You find several boxes with different topics. The first one is getting started. I click on this one, the getting started page. You will find a sum up of the reminder of the offer, and then an operational path to manage the services and the data, how to search, how to visualize, how to download, be informed of events, learn, and to contact and to ask questions to the support. So I don't like the impact this. Sorry, 2 minutes. Okay. So I come back to the user corner. The second one is a really, really important section because it is about the Help Center and FAQ section. So I follow it. Here I join the Help Center website. There are more or less 180 articles about any topics, how to download, how to visualize, etc., etc. You can search by keywords on this area. Download. I can reach the article how to download the Copernicus Marine products. I click on it. You have a table on the right and all useful information to download data using the different services. So it's important to note that we are in a transition period to move from the deprecated services to the new services. So for the moment, products are available using all the services, but at the end of March, only new services will be available only. And so it's important to migrate to the new services as soon as possible, specifically if you have an operational service and a downstream service. So it's important to move to these new services. So it's important to use really this to check this the Help Center because many answers are included. And of course, if the answer is not included, you can contact us. I will show you later how. The third box is about the user notification service. This one, you will find the list of all the operational events, that is maintenances, incident, improvement, etc. So for example, if I go to maintenance section, I'm going to zoom. You can see here that there is several ongoing maintenances, ongoing maintenance on our diffusion tool, and a maintenance related to the transition I spoke about before. You have here the many details on the transition, and so it's important to be informed of all these events. So to be informed, you can create your own RSS feed using the different filters available here, and then you subscribe to RSS feed. And so if your product is impacted, you will receive automatically information using the RSS feed. So it's important to use this functionality. So I come back to the user corner. The next one is user learning services. Here you will find all information about the training workshops. So for example, here you will find the training for the South America and the past event, the next event, etc. Here, the next one is e-learning materials. Following this link, you will find several materials about how to use the data and services. You can select filter by level, by subject, or by tool. For example, you will find several Jupyter notebooks inside. So I let you discover this this section depending on your needs. I come back to the user corner. The next one is a section. Where it is? It's a section dedicated to the quality of the product, so product quality dashboard. You will find useful scientific information, and you can as well filter by the area and the color of the ocean. Blue for physical, green for biochemical, and white for CIs, as presented by Valentina before. And then you will, I'll let you can as well, filter by the parameter. So okay, the same I'll let you discover this this section. I come back to the user corner. The product roadmap section. Here you will find long, mid-term, and short-term the changes the changes planned for long, short, and mid-term. Here for the mid and long term, and at the bottom there is a specific button to have short-term information. I click on it, and for example, I want to be informed of information related to the last release of which was in November. Here I find several cards with information for each impacted products. For example, I click on the first one. Here I will find all the information, the product identifier, and details about the change related to this product. So it's useful in information. I come back to the user corner. Get inspired section. Here you will find all the use cases about with the Copernicus Marine Service data. You can sort by region, country, market, or by keywords. You should find in this section all the user testimonies presented before. The three last boxes, I won't go inside, but the first one is to register. So you have to be registered to access data and to contact the user support. It's important. The Help Center is fully opened. The registration is completely free. So do not hesitate to register. The activation is automatic, and it's quick and easy. The service commitments and license, it's a document to list what are our commitments regarding the service and the performance of the system. And the contact us here, it's just to contact the support. But the best way to contact the support is to use the chat. I don't know. Yes, it is at the bottom right of all the pages. I click on it. So here you can ask a question if you are authenticated. There is as well a link to the Help Center. So you will find the same articles than available in the Help Center I have shown before, and some news. For example, news. It is about the toolbox to access the new services of the Copernicus Marine Service. Information on the toolbox, on for example, the update of the MyOcean Pro, the viewer. You will have information tomorrow. So, and then of course you can contact us here, and you will reach a member of the team to first of all you will meet Blue, which is a companion, and then if Blue cannot answer your question, of course you can ask a human to help you. So do not hesitate to check the Help Center and then to contact us using the chat. It's okay for me. Thank you.
Thank you, Cédric. And thank you. That's very useful so that users can contact us and also discover all the available tools we have on the website. And we are reaching the end of today's session. Thank you, everyone, for coming and for following us during the last 2 hours. I hope this was an insightful session. Today we gave you an introduction to the service and told you about the products and what you can find in the website and service. And tomorrow is going to be a more practical session. We will have a demonstration of the MyOcean viewer, MyOcean Pro, by Gaëlle Durand. She will show us how to visualize the data that is available at the Copernicus Marine Service. And we will have 2 short presentations on the exercises developed using Jupyter notebooks and QGIS software using the Copernicus Marine data. And these tutorials are available online in the events website. There is a tab at the top where you can find Jupyter notebooks and QGIS sections. There you can download the tutorials. There's also videos, the demonstrations, so you can follow. And if you have some time until tomorrow to practice a little bit, go ahead. And tomorrow, Stefania and Alvaro Pascual from Nologin, they will be there. They develop these exercises specifically using data from South America region, so they will be there to answer your questions. So we hope you're there as well. And now, before we leave, I just want to remind you, there is a section at the website of the event. There is a section, yes, that's just what I said, so the Jupyter notebooks and QGIS. And there's also a section next to the Q&A section reserved to the polls. So it's a survey. Would really like to have your feedback on this workshop and what we could provide in the future for you in terms of training or any other training materials. So please take 2 minutes of your time. That would be really helpful. And once again, thank you all of our speakers for today, and I see you tomorrow. Bye-bye.